Well, welcome back. This is Unit 6.1. We're going to be talking about different types of chemical reactions in your textbook. This is page 364 to 397. And in your text practice, it's in your study guide 153 to 160. All right, so before we talk about the 5 different types, basic types of chemical reactions, let's talk about the parts of a chemical reaction or equation. And so here we have NH3. That is the chemical symbol for a compound. It's called ammonia. And then in parentheses behind some compounds, you can see what state that compound is in. So AQ, that stands for aqueous. So what that means is the NH3 has been dissolved in water. So it's aqueous. Then you have your plus sign. This means combines with. So this ammonia combines with water, H2O. And here we see an L. It's a cursive L because sometimes when you write an L with Times New Roman, it looks like a 1. So they a lot of times will put a cursive L like this. So that means liquid water. And then you have a arrow, and this arrow is read as to yield. So ammonia combines with water to yield or to give or to produce. And this is NH4 plus, so that's an ion. That's an ammonium ion, and it's aqueous. And then this second plus sign is read as and. And then OH is the hydroxide ion, and that's also aqueous. So this whole thing reads ammonia combines with water to yield ammonium ion and hydroxide ion. All right, so everything that's to the left of this yields arrow is called the reactants. These two things are reacting together. And then on the right-hand side of the arrow, these are called products, the products that are formed. Now, a lot of students ask, can this NH4 switch places with this OH? So could we write OH plus NH4? And the answer to that is yes. Same thing on the reactant side. We could have written this as H2O plus NH3, and it means the exact same thing. All right, so those are the parts of a chemical equation. Make sure that you pause this video and you write this down. All right, so the first reaction that we're going to talk about, chemical reaction, is called combustion. Okay, this is a combustion reaction. Okay, and in a combustion reaction, we take, and it says ethane is burned. Well, C2H6 is the chemical formula for ethane. Now, a combustion reaction is the same every single time. So it's just going to tell you what's being burned. Then we're going to say plus O2 because you had to have oxygen to burn something. So the last part of this equation is the same for every single combustion reaction. And this yields H2O, water, plus carbon dioxide, CO2. Okay, so this is a combustion reaction. Combustion means to burn. It gives us the compound that's being burned. This part is the same for every single combustion reaction. It always combines with oxygen, and it always yields water, H2O, and carbon dioxide, CO2. The next type of reaction that we're going to talk about is what's called a decomposition. A decomposition reaction. And in a decomposition reaction, you have a compound that's going to break down into other elements or compounds. So here it says aluminum chloride. So now we're going to have to go back and start reviewing writing compounds. All right, so aluminum chloride, that's made with aluminum. Chloride is chlorine. Okay, so this is a metal and a nonmetal that's combining together, so that makes it ionic. So now we need to look at charges. So aluminum is a +3. Chlorine is a -1. So in order to get a proper formula for this, chemical formula, we have to swap and drop. So this 3 is going to come down here. This 1 is going to come down as a subscript, but we don't write 1s. So the formula for aluminum chloride is AlCl3. It's very, very important. You must get these formulas correct, because if you don't get the formulas correct, then when we write the equation will be incorrect. So you have to start off correct to end up with the correct answer. All right, so this says it is heated, leaving or yielding, it's just a different word used, aluminum metal, so that's Al, and chlorine gas. All right, so again, we have to remember our diatomic elements. See, all of this stuff that we've learned in chemistry up to this point, we have to remember, and we have to keep using that. So aluminum metal, aluminum is not diatomic, so you can just write it as Al. Chlorine gas, Cl. Chlorine is one of the 7 diatomic elements, so we can't leave it as Cl. It has to be Cl2. Okay, so this is called a decomposition. Now, the way you can recognize a decomposition reaction is that there's only one reactant, and then you have your yield sign, because that breaks down into other elements or compounds. Decomposition reaction. All right, the next type of reaction that we're going to talk about is called a synthesis reaction. A synthesis. Synthesis means to make. So we're taking 2 elements and we're going to put those together to make a compound. So we have phosphorus. Okay, and this is written as P4, and there's no way that you would know that. So if it's a case like this where there's no way just by reading that you would know the formula, then it's going to be given to you. So there's no way that you would know. I know just from experience that that's P4. Plus, for this particular reaction, sulfur, okay, and that's S8, and again, you wouldn't know that, to form, so there's your arrow, tetraphosphorus. All right, so we do know how to do this. Tetra means 4, so that's phosphorus, P4, trisulfide, so sulfide tri is 3. So that yields P4S3. Okay, and this is called a synthesis reaction because you're taking 2 elements or compounds forming one product. And this is just exactly the opposite of decomposition. So decomposition, you have one reactant breaking down into several. And then in synthesis, you have several, it could be more than 2, it could be 3 reactants making one product. Okay, so synthesis and decomposition are opposite reactions from each other. Okay, the next one, aluminum metal is placed in a solution of zinc chloride to form zinc metal and aqueous aluminum chloride. Okay, so this type of reaction is called a single replacement. Single replacement reaction. And I'll tell you why after we write the equation. So aluminum metal is placed in a solution of plus zinc chloride. So that's zinc and chlorine. All right, so that's a metal and a nonmetal. So we have to get the charges. It's ionic, and we have to balance the charges out. So zinc is a +2. Zinc is always a +2. Remember the stair step, aluminum, zinc, and silver? So aluminum is 3, zinc is 2, silver is 1. Okay, and chlorine is always a -1. So swap and drop, that's going to be ZnCl2. Okay. To form zinc metal plus aqueous aluminum chloride. Okay, and we know aluminum chloride. We did this just a moment ago. So AlCl3, remember aluminum is a +3, this is a -1. Swap and drop, so that's how we get Cl3. All right, single replacement. Now, why is this called a single replacement? That's because this aluminum is a single element not bonded to anything else, and it is going to replace the other metal that's in the compound. So this aluminum is going to kick out the zinc. So zinc is going to now be by itself, and aluminum is going to take its place. So it's a single element replacing another element in a compound. And it doesn't have to be the metal. It could be the non-metal. It could be the chlorine being replaced. But if chlorine is replaced, it has to be replaced by another non-metal. So metals kick out metals. Non-metals kick out non-metals. So aluminum and zinc happen to be the metal. So that's why aluminum is replacing zinc. Now, side note here. You have to look at your reference materials, and there is a section in there where the big black arrow is. It doesn't look exactly like this, uses a little different. But the part of your reference materials that have the big black arrow, that's what you're going to be using now for single replacement reactions. And only stronger metals can replace weaker metals. Now, what do I mean by that? Well, in our reaction, here we have aluminum and zinc. So you're going to have to find aluminum and zinc in the activity series. Okay, so let's find aluminum and zinc. Here's aluminum right here, and zinc is right here. Okay, so increasing activity. So aluminum is more active than zinc. Aluminum is a more active metal than zinc. So what that means is aluminum can kick out zinc. Okay, let me go back. Aluminum is able to kick out zinc because it's stronger. However, this reaction will not go in the reverse direction. Okay, so the reverse direction would be this way. That does not happen because aluminum is a stronger metal, so zinc, being the weaker metal, cannot kick out aluminum. So the stronger metal gets to bond with the negative ion. Okay? All right, so let's look at another one of those. Copper metal is placed in a solution of zinc chloride. Okay, so we have copper metal placed in a solution of zinc chloride to form zinc metal and copper 1 chloride. Okay, so that means copper 1 is the charge of copper. All right, that's U, not an A. All right, so let's go to our activity series. Is copper stronger than zinc? Well, let's erase this. So we know where zinc is because we just used it. And copper is way down here. So copper is weaker. Zinc is stronger. So zinc is going to hold on to its chlorine. Copper is not going to be able to replace zinc because copper is weaker than zinc. So this reaction would not happen. Okay, this reaction would not happen. So what you would do if you had a problem like this is you would say no reaction. No reaction is going to happen. That is not possible. Okay, so make sure that when you have a single replacement reaction that you look at that activity series and first make sure that the reaction is going to happen. Okay? All right. And the last type of reaction that we're going to talk about is called a double replacement. Okay, and in a double replacement, you have two compounds that are just switching partners. So here we have lead 3, so that's Pb, and lead 3, that means that it's a +3 charge, nitrate. Okay, so nitrate is NO3, it's got a -1 charge. So we have to swap and drop, so we have to use parentheses around it because that's a polyatomic ion. So that's the correct formula for lead-3 nitrate. Okay, plus potassium phosphate. So potassium is K, phosphate is PO4. Okay, that's another polyatomic ion. Phosphate is PO4. All right, so potassium is a +1. We get that from the periodic table. And phosphate, if we look phosphate up on our polyatomic ion list, we see that it's a -3 charge. So we have to swap and drop. So it's going to be K3PO4 for that. Okay, so this is, again, you had to remember from your previous studies on these ionic compounds, putting those together so you can get those proper formulas. If you don't, if you need to go back and review that, do that. Because if you didn't learn it the first time, you need to learn it now. Now you're just putting yourself in a behind situation. Okay, so this is going to form lead phosphate. So what happens is these two metals are going to switch places. Okay, that's a double replacement. They're switching places. Okay, the potassium is going to come over here with the nitrate, and then the lead is going to come over here with the phosphate. So we have lead phosphate. So this is Pb. Now remember, that was lead-3 phosphate. So that's PO4. Okay, and phosphate's a -3. So those cancel out. You just smash them together. There's no subscripts needed there. And potassium nitrate, KNO3. So K is a +1. Nitrate's a -1. So those, again, those cancel out. So we just smash those together. So here's a good time to address another misconception. So misconception is because this nitrate has a 3 here, we needed 3 of these nitrates to go with this lead. A lot of students, when they get over here to this nitrate, assume that you have to put the same thing. They assume, oops, get my pen, that because it's written like this on the left side, that you have to do it on the right side, just like this. Okay, that is wrong. Absolutely wrong. Do not do that. What you're doing is you're just trying to balance out the charges in the formula. So just because we have that on one side does not necessarily mean, now it could, depending on the charge, but it's not a requirement just because it's on one side to do it to the other. You just have to make sure that you balance out these charges. Okay, now again, this is called a double replacement reaction. Okay, double replacement. All right, so that's all I'm going to have on today's video. I'm going to cut it short there. All I want you to do is make sure that you have these written down. Okay, we're going to review tomorrow some writing of formulas and practice writing some equations like this. And then we'll have another video. You'll have another video that you need to watch on balancing equations. All right, so like always, make sure you come to class prepared. And if you want to know when I put more videos up on YouTube instead of on Canvas, make sure that you slap that like button right across the face, subscribe, and click that bell notification.